Hello class. Today we're going to be looking at Unit 2-2, which is about direct variation. So direct variation is going to be a condition that two things exist in when they are directly related. In other words, as one thing increases, the other is going to increase as well. And similarly, as one thing increases, the other increases. As one thing decreases, the other one is going to decrease. So our standard equation for direct variation is going to be y equal kx, where k is our constant of variation, and y and x are just going to be variables that we can use. So I've gone ahead and created a table using my x and y values. So in this table I have x values of 1, 2, 3, and 4, and corresponding y values of 2, 4, 6, and 8. So I want to use my equation for my coefficient of variation, which is y equal kx. I know my y value is 2, my x value is 1. So where I have a y, I'm going to put 2 equal k times 1. I can then divide by 1 or multiply by 1. I'm going to get 2 equal k. So k is again my constant of variation, so I know that my k value here is 2. Let's check my second set of numbers and make sure that it works out. So I've got 2 and 4. So I'm going to say 4 equal k times 2. I divide by 2, and I get 2 equal k again. So I see that my coefficient of variation for this equation, or this set of data, is going to be 2. Alright, so I've created another table here using x values of -1, -2, and -3, and y values of -3, -6, and -9. So let's use this table in order to find our constant of variation, which is again our letter k. So go ahead and take about 30 seconds to find this. If you need more time, again, pause the video as you need.
Do you notice that I put them in numerical order?
Alright, so let's look at this. To start with, we've got a y value of -3 corresponding to an x value of -1. So we're going to say -3 equal k times -1. We divide by -1, and we get a negative divided by negative is a positive, so we get k is equal to 3. Let's try another one to make sure. So we've got -6 equal k times -2. We divide by -2, and we again get 3 equal k. So we know that our k value, our coefficient of variation, is going to be 3. So here we've created another table. This table is very similar to the previous one. However, there is a slight difference. So let's again use our equation y equal kx, and let's use that in order to figure out what our coefficient of variation is. So start with our y value is -3 corresponding to an x value of 1. So we're going to say -3 equal k times 1. We divide by 1, and we get k is equal to -3. Let's try our second set to make sure it works. -6 and 2. So we're going to say -6 equal k times 2. We divide by 2, and we get -3 equal k. So again, we see that our coefficient of variation is -3. So this differs from our last example because notice how when we divide a negative by a positive, we get a negative value, as we recall from Algebra 1.